Okay, let's add and subtract some rational functions. This should say adding and subtracting. Okay, so we need a common denominator when we're adding fractions. So I'm thinking, what do 2 and 5 both go into? Well, they both go into 10. So if I multiply the left fraction by 5 over 5 and the right fraction by 2 over 2, then I'll have 10 as my denominator in both of these. And I'm really just multiplying them both by 1, so I'm not changing the values here. So I've got 5 over 10. That's equivalent to 1/2, right? And then 8 over 10 would be equivalent to 4/5. Now, I just add the numerators, so 5 plus 8 is 13, and keep the denominator the same. And I've got 13/10. Okay. All right, so next up, hey, I'm subtracting fractions. I need a common denominator. Oh, look at this. We already have a common denominator. Well, that's good luck. So I just leave that the same, and I'm going to subtract the numerators. Be careful when you do this. Even though this is a simple problem, there's an easy mistake to make, and that is to only subtract the 2x. So if you write this without parentheses, it's not the same thing, because we've got to distribute that negative symbol. Okay. And then I'm going to combine like terms up there. 3x minus 2x would be x, and negative 4 minus 5 is negative 9. And then I check to see if there's any more reducing I can do. You can't cancel out those x's because they're added and subtracted to different things. So those are terms of the numerator and denominator, not factors. So I can't cancel or reduce them. Same thing with the 9 and the 3. Okay, so there we go. All right, so some general guidelines for adding and subtracting rational functions. Factor the denominators. That's going to come into play on this next problem on the left fraction. Okay, and then we're going to find a common denominator. All right, and if you have we're always going to have multiple fractions, so we're going to combine those fractions. And then we'll factor again because it's possible that we can reduce. And then we're also going to list the canceled undefined x values. And I'll get to that in these examples coming up. But there's our basic strategy for these problems, okay? So looking at this, first thing I want a common denominator. I could multiply this by x plus 1 over x plus 1, and this by this trinomial over this trinomial, but that would be a big mess. So let's try factoring. It's going to simplify things. So you can do a diamond problem here. Remember, you can put 3 on top, 2 on bottom. Looking for two numbers that multiply to 2, same numbers add to 3. It's going to be 1 and 2. Okay, and now when I write this problem like this, now it's a little bit easier because I can see that the denominators already have something in common. They both have an x plus 1. So if I just do this, then I'll have a common denominator, and I can do that as long as I do the same thing to the numerator up there. Okay. All right. So let's simplify this fraction a little bit. Let's see. I've got x minus 1, x plus 1, x plus 2. Okay. I'm going to distribute this over here. And then I'm actually going to leave the denominator factored. I usually leave the denominator factored because it's possible at the end of the problem that you'll be able to do some reducing. So I'm going to leave it like that for now. Okay, so then I can combine these into one fraction. And I don't really have to worry about using parentheses when I'm adding because I'm not going to distribute anything there. But now this is combined into one fraction. Okay, and I want to still go about simplifying this, so I'm looking in the numerator and thinking, oh, I've got some like terms there. So 1x and 2x would be 3x. Okay, And at this point, I want to, so I still left the denominator. I actually am just going to always leave the denominators factored. You could multiply it back together if you wanted at the end or at any point. But I want to see if I can factor the numerator to see if I can reduce this further. So I'm thinking diamond problem. But multiplying to get -1, there's really only one option, 1 and -1. And those don't add up to 3. So this one's not factorable, which means we can't do any more reducing here. So this is finished. Okay, let's try another one. All right, so looking at this, I want to factor that first denominator. So let's see, I can do a little diamond problem in the margin here. And for two numbers that add to 3 and multiply to -4. So 2 and 2 is not going to work. 1 and a 4 will work if the 1 is negative, the 4 is positive. So let's see. Okay, so now looking at that, the denominators now have something in common. So what I can do, the one on the right's just missing the x minus 1, so let's add it in. And I just have to do the same thing to the numerator then, okay? All right. Sometimes I'll see people then just cancel these out, but that's just going to get us right back where we started, right? Okay, so now we can combine this into one fraction. Also, I'm going to distribute this while I'm at it. So my first numerator is x minus 3. My second numerator is going to be 2x squared minus x. So I was doing that distributing up there, right? And this is all over x minus 1 times x plus 4. Okay? And I do want to clean up the top. I'm going to leave the bottom factored. Because sometimes we end up being able to do some more canceling. But it's gonna, so I've only got one x squared term up there. And then for my x's, those are actually gonna cancel out. So I've got a negative x and a positive x. Oh, you know what? Never mind. When I distributed that, that should have been 2x squared minus 2x. I was having a feeling that those shouldn't cancel. Sorry, that should be a negative 2x there. Okay, and then when I combine these, I'm going to get negative x. And then there's the negative 3 as well. Okay, so I still should factor the numerator because it's possible that I'll be able to do some canceling. Okay, you could do a modified diamond problem. I'm just going to do this by hand. I'm thinking, well, I know those are going to be my firsts, right? In order to get 2x squared. And then to get 3, it's going to have to be a 1 and a 3, or a 3 and a 1. So I kind of am just playing around with the possibilities. You know, you can use maybe use a pencil. If I put a 1 and a 3 like this, then I'll have a 6x and a 1x. But I can't get to negative 1x from that. So let me switch these, see what happens. So now I'll have a 2x and a 3x, and I can make a negative x out of that if the 3x is negative and the 1x is positive. So now that's factored. Okay, and I'm just looking for any more canceling that I can do, but there isn't anything to cancel. I'm close with the x minus 1 and x plus 1, but I can't do anything with that. Okay. So you could have left it like this, actually. It doesn't matter, but you do want to factor it just to make sure that you can't reduce anymore. Okay. And I didn't cancel anything out of the denominator, so I don't need to list any undefined x values. Okay. All right, let's give this next one a shot. So I can see the denominators here. I can factor both of them. I'm just going to factor these in my head quickly. So I'm looking for two numbers that multiply to negative 3. Well, if I have negative 3 and positive 1, then I can get a negative 2 out of those as well. Okay. and then two numbers that multiply to -6. So it's either going to have to be 1 and 6 or 2 and 3. I'm going to have to use the 2 and the 3 in order to get to a -1x. So it would be a +2 and a -3. Okay? And now this is useful because now I can see that we've got something in common in both of these, in both of the denominators. Okay? So if I want these to have the same denominators, I just need to add in whatever each denominator is missing, right? So this has an x plus 1 and an x minus 3, but it doesn't have an x plus 2. So let's just multiply this by x plus 2 over x plus 2 here. Okay? And then this one's missing the x plus 1. Okay? I mean, in the beginning, you could just multiply both fractions by the other trinomial, but then it'll be a giant mess. It's much easier to factor it and do as little multiplying as you can. Okay? And then, so I'm going to clean up these numerators a little bit. I'm going to be distributing. Okay? This is all going to be combined now into one fraction. I'm going to leave the denominator factored. Okay, and then that first numerator is going to be 2x plus 4, the quantity 2x plus 4. And I am putting this in parentheses here because I'm subtracting these two things. So this is 3x plus 3, but I'm subtracting that whole second numerator. So that means I'm going to have to distribute the negative there. A lot of times people will forget to distribute the negative to that last term. Okay, I can clean up the numerator now. So 2x and -3x gives me -x. 4 and -3 gives me 1. Okay, and looking at this, it's tempting to try to do some reducing here with the -x plus 1 and x plus 1, but we can't. And they're not even opposites. I could factor out a negative on top, but then I'd have -1 times x minus 1, and I still wouldn't be able to reduce there. So this is going to be my final answer. Okay, next problem. This one's going to be a little bit of a pain. I can't do any factoring here, and they don't have anything in common. I mean, it's not too bad, but the only thing we can do to get a common denominator is multiply by x minus 3 on this first fraction and x plus 2 on the second fraction. And then they'll have the same denominators, right? So on both ends, I'm going to be distributing here. I'll combine this into one fraction, so I'll just have x minus 3 times x plus 2 as my denominator. Okay, so the first numerator is going to be 3x minus 9. And I distribute the 3. Second numerator, 4x plus 8. And I put that in parentheses because I want to remind myself that I have to distribute there. Okay, leaving the denominator factored. And then let's clean up the numerator. 3x minus 4x is -x. -9 minus 8 would be -17. Okay, and there's no more factoring I could do. I suppose you could factor out a negative if you like in the numerator, but it's not going to lead you anywhere. You could multiply the denominator back together, but just make sure you've checked for any factoring. Okay. All right, so next up we've got some complex fractions. Complex fractions, that just means we've got more than 2 layers in our fraction. Okay, so this can look intimidating, but the way to handle it is to just think of it as a division problem. Okay, so this is going to be, think of that as a division symbol. So this would be 2/3 divided by 4/5. Okay, and then I can rewrite that as multiplication by flipping the second fraction. And then since it's multiplication, I don't need a common denominator. I just multiply straight across. So I'm going to get 10 over 12, and I do want to reduce that. So 5/6. Okay. All right, let's try this one. So again, I'm going to write this as division and then as multiplication. Okay, and then I'm going to get 2x over 4x. And then we can reduce a little bit. In fact, the x's are just going to cancel, right? And then I've got 2/4, which equals 1/2. Okay. Now, I wanted to show you this problem in particular because there's a pretty handy little shortcut. When you've got a complex fraction like this, where you've got a fraction in the numerator and a fraction in the denominator, if they have the same denominators, like they both have x as their denominators, these denominators are just going to cancel out. And then you'll wind up with 2/4, which is 1/2. So it's a nice, handy little shortcut. Okay. Okay, these problems can get a little more complicated, but it's that same basic principle that you're going to write this as division and then as multiplication. Okay, now this gets trickier with this problem because we got more going on. So when there is more than one term in the denominator, we have two terms in the denominator. We want to combine the terms before dividing. Because if you flip it into multiplication, you can't just flip multiple terms like this upside down. So what I would do is just combine these two into one term to begin with. So I'm thinking, okay, I need a common denominator for x and 2x. Well, my common denominator would be 2x, right? So that's what I'm going to have to do in order to combine those. So let's see. So I've got 6 over 2x plus x squared over 2x. Now I can combine these, just leaving the top alone for now. Okay, and I got it down to this. All right, so now at this point I can write this as division. And then in turn I can write that as multiplication. So I'm flipping that second fraction. Okay, and now remember multiplication, no common denominator needed. So we can just combine this into one fraction actually. So that's what I'm going to do. I'm going to write that like that, and then I'm going to start working on simplifying this. So I can cancel these x's, okay? And then there's no more factoring I can do in the numerator or the denominator. So let's just clean up this numerator. I'm going to call that 2x minus 2 in the numerator. I suppose you could leave it factored. That would be fine. Okay. And then I want to think about any undefined x values here. Whoops, I'm off screen a little bit. So I did cancel out an x here, so I couldn't plug in 0 for x into the original problem. Okay. And then looking back, that's the only denominator that I've canceled. So then I'm good to go. Okay. And that is it for today. See you next time.